Hello people, so how are you doing today? All is well? In the last video session, we had covered the concept of big data. Let's review some of the concepts that we discussed earlier. Cluster computing is the term that refers to a set of computers connected to a network that performs like a single entity. Each computer connected to the network is called a node. Commodity hardware is the term used to represent devices that are available at low cost. These devices can be clustered together to enable harnessing of processing power of all the systems. Big data is extremely large data sets of varying types of data, structured, unstructured and semi-structured, that can be collected, stored and later analyzed to provide large insights for the organizations. How do you think that Hadoop comes into picture? Is there any association between these three terms? Cluster computing, commodity hardware and big data. Hadoop is a framework for big data processing. Hadoop uses the concept of cluster computing on commodity hardware for processing big data. Now I hope you got the answers to my question. If not, please review the above concepts again. When we want to process big data, we need to take care of two things: storing data and processing the data. Hadoop takes care of both these requirements. Let's see what Apache has to say about Hadoop. The Apache Hadoop project develops open source software for reliable, scalable, distributed computing. The Apache Hadoop software library is a framework that allows for distributed processing of large data sets across clusters of computers using simple programming models. It is designed to scale up from single servers to thousands of machines, each offering local computation and storage. Rather than rely on hardware to deliver high availability, the library itself is designed to detect and handle failures at the application layer, so delivering a highly available service on top of a cluster of computers, each of which may be prone to failures. So now you can connect the above three terms: cluster computing, commodity hardware and big data. Hadoop is used as a framework for big data analytics for the following reasons. The first reason is that it provides a huge amount of storage. Data is distributed across clusters of computers. Second reason is that it provides high reliability and scalability by replicating data across the cluster. Third reason is that it moves processing to where data resides, termed as data locality, rather than moving data to where the program resides, as in the classical approach. Fourth reason is that it provides a MapReduce programming model for parallel processing of huge amounts of data. These features of Hadoop are in line with the requirements of big data processing, which are storage and processing of terabytes and petabytes of data, avoiding bandwidth bottlenecks while moving data between computers, avoiding a single point of failure as it will lead to the whole data to be lost. The data we are dealing here are petabytes of data. So the crux is that Hadoop very well suits as a framework for big data processing. Let's delve into how all this started in the first place. Hadoop was developed by Doug Cutting and Mac Caffarelli in the year 2002, when they both started to work on Apache Nutch project. Apache Nutch project was the process of building a search engine system that can index 1 billion pages. After a lot of research on Nutch, they concluded that such a system will cost around $500,000 in hardware, and along with a monthly running cost of $30,000 approximately, which is very expensive. So they realized that their project architecture will not be capable of scaling with billions of pages on the web. So, they were looking for a feasible solution which can reduce the implementation cost as well as the problem of storing and processing of large data sets. In 2003, they came across a paper that described the architecture of Google's distributed file system called GFS, Google File System, which was published by Google for storing the large data sets. Now they realized that this paper can solve their problem of storing very large files which were being generated because of web crawling and indexing process. In 2004, Google published one more paper on the technique MapReduce, which was the solution of processing those large data sets. These both techniques, GFS and MapReduce, were the solution for their Nudge project. Tom Cutting understood from his work on Apache Lucene, which is a free and open source information retrieval software library originally written in Java by Tom Cutting in 1999, that open source is a great way to spread technology to more people. So, together with Mike Caffarelli, he started implementing Google's technique as open source in the Apache Nudge project. In 2005, Cutting found that Nudge is limited to only 20 to 40 node clusters. He soon realized two problems. Nudge wouldn't achieve its potential until it ran reliably on large clusters, and that was looking impossible with just 2 people. The engineering task in Nudge project was much bigger than he realized. So, he started to find a job with a company who is interested in investing in their efforts, and he found Yahoo. Yahoo had a large team of engineers that were eager to work on this project. In 2006, Tom Cutting joined Yahoo with the Nudge project. He wanted to provide the world with an open source, reliable, scalable computing framework with the help of Yahoo. So, at Yahoo, first he separated the distributed computing parts into a new project Hadoop from Nudge. Now he wanted to make Hadoop in such a way that it can work well on thousands of nodes. So, based on the concepts of Google File System and MapReduce, he started to work on Hadoop. In 2007, Yahoo successfully tested Hadoop on a 1000-node cluster and started using it. In January of 2008, Yahoo released Hadoop as an open source project to Apache Software Foundation. And in July 2008, Apache Software Foundation successfully tested a Hadoop cluster having 4000 nodes. In 2009, Hadoop was successfully tested to sort a petabyte of data in less than 17 hours for handling billions of searches and indexing millions of web pages. In December 2011, Apache Software Foundation released Apache Hadoop version 1.0. And later in August 2013, version 2.0.6 was available. And currently, we have Apache Hadoop version 3.0, which was released in December 2017. Let's summarize the history of Hadoop. It all started in 2002 when the developers of Hadoop started their work on Apache Nudge. In 2003 and 2004, Google published papers on MapReduce and Google File System. In 2006, Tom Cutting joined Yahoo with the Nudge project. In 2007, Yahoo successfully tested Hadoop on a 1000-node cluster. In 2008, Yahoo released Hadoop as an open source software to Apache Software Foundations. In 2009, Hadoop was successfully tested on a petabytes of data. In 2011, Hadoop version 1.0 was released.